Hello, today I will prove Schur's theorem, which tells us that if we consider any integer coefficient polynomial p of x and a set of q set of primes, each of qi divides at least one element of pj, the j is the positive integer, then we need to show that size of q will be also infinite. To prove this, we need to discuss several cases that if p of 0 equals 0, in this case, a0 must be 0. In this case, if we discuss p of any prime number t, this number will be always divisible by t because of Bezos' lemma. So we know that size of primes will be equal size of q. Now discuss the case. So because we know that size of primes is infinite, so size of q will be also infinite. Now let's discuss the second case. Then p of 0 equals 1. If p of 0 equals 1, then now let's discuss the q of t, which is the largest element in q. This is maximal. Now let's take p of n. There n is the not p of n factorial. P of n factorial. There n is greater or equal q of t. Then we will see that this number equals 1 mod q1 times q2 times up to qt. Because we know that all these numbers x is divisible by q1, q2 up to qt, because n factorial is number which is divisible by q1 times q2 times qt, and we know that a of 0 equals 1 mod for every this prime number. So we will see that this number will have different prime which is not in q. So we can generate another number q of t plus 1 which is not in q. And this is our contradiction, that size of q was finite. So if we make this process infinitely many times, we will prove that size of q will be also infinite. Now let's discuss this case. Then p of 0 doesn't equal to 1. So this was case, then p of 0 was 1. Above was case, then p of 0 was 0. In this case, let's take another polynomial g of x such that g of x equals p of x times f0 over f0. No, not p of 0. P of 0. What can we say about g of 0? G of 0 is clearly 0, not 0, 1, sorry, because this is p of 0 over p of 0, and this number is clearly 1. And we can also see that this polynomial has integer coefficients, because all of the numbers in a px times p of 0 is divisible by p0. So if we imagine that p of x p0, this number equals ak to the x to the k, p to the p0 to the k, then up to so on, and last numbers will be a1 times x times p of 0 plus p of 0. And if we divide all these numbers p of 0, we will see that all of its coefficients must be also positive integers. So if pi equals p0 to the I times ai over p0, this number must be p0 to the I minus 1 times ai, and clearly this is positive integer. So we have proved that g has integer coefficients and g of 0 equals 1. And now we get back to the previous case, but we have different polynomial which is clearly dependent on p of x. And if we know that g has infinite number of prime factors, this sequence g0, g1 up to g infinity, then we can conclude that p will have also these prime factors, so the size of Q must be also infinite. So we have proved this one. This was all I wanted to discuss for today. If you want to discuss some theorems, please write in the comments and don't forget to like and subscribe.